new project. This is called dimmer switch using MOSFET. MOSFET 2N7000 small signal. And then we are using a potentiometer, a straw hat LED with the current limiting resistor, and the power LED blue. Let us test the circuit. We're going to use our workbench power supply and positive, negative, positive. Adjust the voltage. How about 3 volts? At 3 volts, we have the power LED. And turning this potentiometer. This is the potentiometer. So we have now this dimmer switch using the MOSFET. How about 5 volts? At 5 volts, we have this bright LED. So we can use this circuit using 3 volts up to 5 volts. Now we have the circuit diagram of our project. So we have the MOSFET 2N7000 gate drain source to the ground. This is the symbol. Gate drain source, the same. This is a enhancement type. And the actual SGD, or in a TO220 package, that is the pin out. And then for our potentiometer, supposedly it is we're going to rotate it, adjusting the potentiometer clockwise. So initially, it is the wiper is pointing to the pin 1, indicating that this is 0 ohms up to 500 kilo ohms. We're rotating it clockwise. Referring to our diagram, it means we are moving it upward from 1 to 3. Here from 1 to 3 clockwise, here upward 1 to 3, the same, and then we have the output LED white for 70 ohms current limiting resistor, and then connected to the supply and then the drain. And we have this power LED blue connected to the 5 volts. So we know that the circuit is on. Once we powering on the circuit using from 3 volts to 5 volts, LED turns on, this power LED. What makes this circuit a dimmer switch? How does it work as a dimmer switch? By dimming this output LED, dimming the output LED, Since the gate is connected to the wiper, pin number 2, this is pin number 2 of the wiper, connected to the gate. So once initially it is connected to pin number 1. So 0 ohms. It means that the MOSFET is grounded. So there is no voltage across gate to source, causing the LED to turn off. Once we adjust the potentiometer to the right or clockwise, it will develop a voltage across gate to source because now the wiper is now located, for example, somewhere here in the middle. There is now a voltage developed across gate to source. Since the current flows into the pin number 3, to the 1, to the 2, it develop a voltage. This is a voltage driven device. So once the voltage developed here is around 2 volts from gate to source, gate to then to the ground, or it means this potentiometer now act as a voltage divider because the wiper now moves upward. So voltage develop across gate to source. Because of that, it will increase the voltage slowly or gradually. Gradual increase of the voltage when you adjust it clockwise, the same as adjusting the wiper or the arrow upward. Once it reaches pin number 3, it will fully turn on. So the cause of dimming an LED, or to make this MOSFET works as a dimmer switch, we need to adjust the potentiometer, moving it upward, downward, or in reality, turning the knob clockwise, counterclockwise, clockwise, counterclockwise, causing to develop a voltage across gate to source, and then causing the LED to dim or slowly brightening or lighting the LED. You can turn it on or turning it off. So this is the output. The output is connected, or the white LED connected to the 5 volts and then to the drain. So once the current flows here, there's also a current that flows to the gate. Since current is not this is not a current driven, once the current flows into the potentiometer, it will develop a voltage causing the gate to open. Once the gate is open, now the current flows from this LED out, drain to source, then to the ground. So this MOSFET act as a switch, a dimmer switch.